Hello, and welcome back to learning more about plate motions. Today will be a longer lesson, so get comfortable. We will also be on the simulator today, along with OneNote. Some of you have started asking when things are due. I always recommend that you do them on the day that I assign them, but I will give you up to 5 days to complete the day's work. You can still turn the work in after the 5 days, but I may not grade it immediately. So that means Monday's work will be due by this Saturday, Tuesday's work will be due by Sunday, and so on as listed here. Today's work, since this is Thursday's work, will be due by next Tuesday. As a heads up for you also, speaking of next week, I will be assigning the midterm on Monday. Given everything that has been happening lately, I will not be counting the midterm toward your grade. However, you should still do your best. As always, it will be timed, so make sure that you are in a place where you can work on it uninterrupted. So we're going to move on to today's work now, and we're going to focus still on our question. What happens to the plates and the mantle at plate boundaries? By now you should have some idea about what's taking place here, between the article and the work that we've done. But we're going to do some more models and simulations today so that we can create a fully developed answer to this. You're going to make a small model by filling in what you think happens at each type of plate boundary. Go into OneNote and look for the page marked explaining what happens at plate boundaries. On this page, you will find two different plate boundaries, one for convergent, like you see here on our page, and one for divergent. Below there will be 4 different squares. You need to choose one square for each of the different type boundaries. If later on you need to revise your model, you will have a chance later in this video. Please don't get rid of this or do anything else with it at this time. You're going to need it for later in this lesson. We'll be adding more things to this. Now that you've completed the model in OneNote, we're going to work with a more complete model that we'll find in the sim. Today you're going to create two situations, one where rock is added to the edges of both plates, and another where the plate sinks into the mantle. What you're going to do is you're going to log into the simulator, go to region 2 this time, add rock to both sides of the plate boundary, and set the boundary to either convergent or divergent. Run and watch the cross-section view. That's the bottom one. Pay attention to what's happening. Was rock added from the mantle, or did one plate sink into the other this time? Run the simulation a second time, except that this time, switch it so that use the opposite. So if you used divergent plate boundaries before, use convergent this time. And if you used convergent previously, go ahead and use divergent this time. Go ahead and pause the video right now so that you can run these two scenarios. Now that you've run both scenarios, let's see if you've been paying attention. By now you've gathered evidence for both types of plate boundaries. See if you can complete this sentence. I saw that rock from the mantle is added to the edges of both plates at either the convergent or divergent plate boundaries, where the plates move toward or away from each other. Take a minute, pause this video, and see if you can figure out the right answer. The correct answers for this one is that I saw the rock from the mantle is added to the edges of both plates at divergent plate boundaries, where the plates move away from each other. For those of you currently laughing at my handwriting, keep in mind I've had to read all of your work all year too. How would you complete this sentence now? I saw one plate sinks into the mantle and is destroyed at convergent or divergent plate boundaries, where the plates move toward or away from each other. Take a minute and answer this. Hopefully you figured out that in this case one plate sinks into the mantle and is destroyed at convergent plate boundaries, where the plates move toward each other. There is a lot to keep track of when comparing these two types of plate boundaries. One of your jobs this unit is to look for evidence to identify what is happening at a particular plate boundary, specifically this time the boundary between the South American plate and the African plate. One way to do this is to look for general patterns at convergent plate boundaries on Earth and to look for general patterns at divergent plate boundaries on Earth. Then we can check to see if any of those patterns match the patterns at the boundary between the South American plate and the African plate. So right now, go ahead and run the scenario a third time with again having continents on both sides of the plate boundary, and set the plate boundary to divergent. This time I want you to make sure that you have turned on the earthquake and volcanoes section. As you do so, pay attention to what you see in both the map and the cross-section views. What landforms are associated with this type of plate boundary? Pause this video and go ahead and run the simulation. Now you're going to run the simulation again, but this time change it from divergent plate boundaries to convergent plate boundaries. Make sure after you hit run that the earthquakes and volcanoes are still on. What do you see this time in the map and in the cross-section views? What landforms are associated with this type of plate boundary? Pause the video right now and run this final simulation. Ready? At this point, you have enough information to go back to the work that we started yesterday on the comparison chart and finish off these last 3 rows. These will be graded by next Tuesday, so please make sure that you have completed the first 2 rows as well as these final 3 rows. You are allowed to check off more than one, so if you see multiple things, go ahead and check them off. Check off only the ones that you see. For the yes/no questions, please check off only one. If you check off both, you're going to be wrong automatically. As you saw from the plate movement here, that plate motion causes earthquakes. However, we also saw this time that not only did we see earthquakes, but we saw volcanoes as well in the simulation. Remember that volcanic activity is any of the many processes, such as eruptions and lava flows, in which gas, lava, and ash are pushed out on the surface of the Earth. As always, if you need to remind yourself of any of the vocabulary definitions, the glossary is located inside of OneNote, as well as all of these videos you can go back and review for any of the previous definitions. It's time to go back to the models that we made at the start of this video, inside of the Explaining What Happens at Plate Boundaries sheet in OneNote. You're going to go back, and now you're going to add to your models. For both types of plate boundaries, draw arrows on each of the plates showing which direction that plate is moving. You should have 4 arrows, 2 for each type of boundary, because each boundary is connecting 2 plates. Label one with a trench that's formed, and the other with the mid-ocean ridge that is formed. Where the rock from the mantle is added to the edges of both plates, put a plus sign there. Where the plate sinks into the mantle and is destroyed, please put where it's destroyed with a minus sign. We'll take a look at this one as an example. Remember that with your plate boundaries, you should have 2 arrows going in a direction. You have to mark the correct direction. These are just examples here. As well, you need to mark it with either a plus sign or a minus sign, depending on the type of plate boundary that we're looking at. Don't forget that you also will need to either type or write in whether or not you see a trench or you see a mid-ocean range. If you need to change the picture in there based off your new information, please do so at this time, and then write in all the information that you need to. That's everything for today. Don't forget, if you need to get a hold of me, send a message on Schoology, send me an email, comment below on the YouTube video, and always, of course, remember to like and subscribe what you see here, because after all, we're going to be spending a lot of these videos together, and you always want to know when the next one's coming. That's all we have for today. We'll have another lesson ready to go for you tomorrow. Thanks, everyone.